We have discussed transistors as the building blocks of computers, and we have learned that our computers are made up of billions of them. How is that relevant at all? The point of all this really is to show that at a basic level, your computer stores data as a series of electrical charges that are either on or off, 1 or 0. Each one of these is referred to as a bit. A bit, therefore, can be either 1 or 0. So how do computers translate these bits into larger numbers? Computers operate on the binary number system rather than the decimal number system. Consider our system of numbering. We all remember back in kindergarten when we learned about numbers. Remember these things? Ones, tens, hundreds, thousands. These all represented one part of any number. The first being the ones, then the tens, then the hundreds, and then the thousands. When we count, we increment this number here, and we keep incrementing it until we can't increment anymore. Then we increment the next column and reset to 0. These numbers can be also broken up so that we can see how many of each kind we have. Also note that each number is 10 times larger than the one before. That's because we have 10 numbers. This is a base 10 system. Computers operate on a base 2 number system. They have only ones and zeros. Other than that, they operate the same way. As we count, we increment the number in the first column. Then when we can't increment anymore, we increment the next column and reset to 0. Because this is a base 2 numbering system, these numbers are each 2 times, rather than 10 times, larger than the one before. So we have the ones column, the twos column, the fours column, the eights, the 16s, the 32s, and so on. And just like the base 10 numbering system, we can use this to determine how many of each type we have. If we want to convert a number from binary to decimal, we simply multiply it out like this, and then add the numbers together. Note that this can be done with any number of digits. Two other numbering systems often used by computer scientists are octal and hexadecimal, which are base 8 and base 16. In base 8, we use the numbers 0 through 7. And in base 16, we run out of numbers at 9, so the letters A through F are used to count for numbers 10 through 15. Both of these operate the same way as binary and decimal, but because they are power of 2, they just work out better for math purposes for IT folks. Now that you're aware of them, you'll probably notice hexadecimal numbers here and there.